This video goes over why does the first number plus the second number equals the second number plus the first. For example, why does 2 plus 5 equal 5 plus 2? Or in the algebraic sense, why does A plus B equal B plus A? I would like to share my outline of this video so you will know what I'm discussing about and in what order. First, I'll discuss that this property that A plus B is equal to B plus A is an axiom, and also give the definition of what an axiom is. Second, I'd like to share my visual ideas for addition that I'll be using in this video. Thirdly, I'll explore the case when you add positive integers together. Then what happens when one of those numbers, or both of them, is positive but is not an integer. Or what happens when you add a positive number and a negative number together, or two negative numbers. Lastly, I'll be discussing what happens when you add 0. I would like to say that this property, that A plus B equals B plus A, is an axiom. What this means is that it is a statement that is assumed and cannot be proven. So in this video, I will not prove that A plus B equals B plus A. However, I'll use visuals, ways of seeing, to show that this makes sense. Which leads me to my next point. What are these visuals? I would like to tell you what visuals we'll be using in this video to show addition. A visual is something that you see. So you want to see addition, not to simply write it down. Suppose I want to see 4 plus 3 and solve it. One way to do so would to be use counters. In this video specifically, they will be pom-poms. So I would count 4 pom-poms and put them to the left. 1, 2, 3, 4. I would count 3 pom-poms and put them to the right. 1, 2, 3. Then I'll add up the total. 1, 2, 3, 4, 5, 6, 7. So the total is 7. Therefore, 4 plus 3 equals 7, because 4 pom-poms plus 3 pom-poms is equal to 7 pom-poms. Another visual, another way to see addition, is using a number line. In this video, we'll be using a ruler to represent a number line. So suppose I want to solve 4 plus 3. I can start at 4, and then I move 3 steps. 1, 2, 3. I see where I land at, and it is 7. So therefore, 4 plus 3 is equal to 7. We can also use 2 rulers when we want to add negative numbers, or a negative and a positive number. This ruler represents the negative part of the number line. This ruler represents the positive part of the number line. To solve, say, negative 1 plus 3, I can start at negative 1 and move 3 steps forward. 1, 2, 3. I see where I land at, and it is at 2. So negative 1 plus 3 is equal to 2. Now, while I'm on the topic of these visuals, of these ways to see addition, I like to show that they are basically the same idea. Now, having rulers does make it easier to add negative and positive numbers, or just negative and negative numbers, but they're basically the same idea, and I want to show why. To solve 4 plus 3 equals 7 by using a ruler, I have to first get to 4. But how do I get to 4? I start at the very beginning at 0 and move 1, 2, 3, 4 steps. Moving 4 steps can also be thought as 1, 2, 3, 4 pom-poms. Then I want to go 3 more steps forward. 1, 2, 3. Using the pom-pom method, you could imagine this as 1, 2, 3 more pom-poms. So you see that combining steps or combining pom-poms, they're basically the same idea, and they both end up at 7 and are correct ways to add. So you can see that the number line way and the counters way are basically the same idea.
The next part of this video is about positive integers, also known as counting numbers. You can click on the link as shown here below.